Okay, so then let's start. So thank you everybody for being here. I mean, after the second seminar of the week, that's quite a good audience. Okay, and also thanks for the speaker to come for coming because he is actually doing a kind of continuous traveling in the last week from Valladolid to here. Just a short introduction, and then we start with the talk. Rafael did the PhD in the UCL with some people that we have collaborated in the past, Mike and I guess and Elsa, no? Or in his group. And after that, he had a Okay, now yes, it was a little. And after Oxford, he's now in Vienna in the Complexity Hub. And well, that's essentially kind of short story. What he's going to talk about is about crime in Mexico. That is quite an interesting work. And he has some others. So he will be here also this afternoon. And well, tomorrow, I'm not sure if tomorrow in the morning you are going to be here too or not. But if someone wants to talk to him, there will be also some opportunities. Okay. So well, the floor is yours.
Thank you very much. First, everyone, for being here. Thank you, Jose, for inviting me. It's a pleasure to be here and to talk about crime because it's like sort of my research. And it's sort of my research because, short story about me, I'm from Mexico City. I grew up in there. I studied applied mathematics in Mexico City. And after I finished my bachelor's, I didn't know what to do in my life. As many of us, right, we have the opportunity to experience and to change whatever we're doing. And for some really random reason, I actually work for the police department. So this is a photo of me in the police department in Mexico City with my team in the police department. From left to right, there's a mathematician, Irving, but people that actually worked with experience in the police. So a person that worked with transit, a person that took photographies of all the high crime profile people, the third one, federal ministry, a person from the army is the lady that is right to my left. She is brilliant. She's finishing her PhD, Marina, an economist and also a police officer. And like that was my work for like, well, I thought I would last in the police maybe 6 months, something like that. But it became the job of my life. So I actually lasted in the police like 5 years. And working in the police in Mexico City was really exciting. This was my last day in the police, and you can tell I'm super tall from being a Mexican because I'm not standing anywhere. Like I'm just surrounded by my colleagues from the police. And it was working with them on the left-hand side of the picture and the brain, let's say on the right-hand side, trying to get together a strategy for constructing a safer city, right? And that's what I did for 5 years. And then I did a PhD and a postdoc, and now I'm a researcher in Vienna. But I'm going to talk a bit about what I do for research in terms of crime, okay? This is actually the secret bunker in Mexico City. It looks like this. On the outside is a bunker that is supposed to survive any zombie invasion, any big whatever war that happens in Mexico. This is the secret bunker. It's not secret because you can Google it. Obviously, it's big. Just the construction of this bunker costed $500 million because it's so expensive. It not only includes a building, but it includes this, that is where we answer 911 emergency calls, or 112 or 089 that is private. So you can denounce anything like, hey, I know of this corruption, but it's private, right? You don't have to tell your name. And we have, and that's why it costed so much, in this place, security cameras, CCTVs, where we monitor around 60,000 cameras in the city. And with 60,000 cameras in the city, now is one of the most surveilled cities in the world. Back then, we thought with 60,000 cameras, we were going to actually make a safer city, right? And we did. Somehow we follow potential criminals in these cameras, and we actually have 5 centers like that, just waiting for a crime to happen. We monitor suspicious people, and by suspicious people, means we try to find in the camera something that looks weird or off, and then we follow you for hundreds of cameras until you do something, and then we arrest you. And that was the plan for Mexico City, and it works actually. Just there are so many ethical issues here, because if you think about it, what does it mean to be suspicious? As in the US, suspicious means basically being brown, right? That's how we train humans. That's how the police works. Blonde lady is never suspicious. Brown guy is always suspicious. And that is super challenging in the ethical way, but that's how the police works, and that's how algorithms work, right? Anyway, in this center, we actually have like the capacity for reacting as a city. And that means reacting for earthquakes, because there are earthquakes in Mexico City, floodings, an active volcano, droughts. We have, it's a city that is 2,400 meters above the sea level. So sometimes the level of pollution is huge. And there are around 30 million people in the Valley of Mexico City. So that's how the challenge is, and that's how it's such an industrial project. And based on that, I'm going to show you a bit of the data for crime and things that us as physicists, mathematicians, or people doing research in complex systems, we can contribute to this sort of topic, right? First is talk about crime and place, crime and time, crime and opinions, and cartels, right, or networks. So if you have any question, please stop me. If you have any comment, please stop me for anything that you want to say. And in terms of place, it's very easy. Imagine that every crime that gets reported to the police, and this is very important, that means somebody went to the police and said, hey, I suffered a crime here. Then you can think of a pattern, right? And why a pattern? Because crime scientists, we believe, and I say we because I did my research mostly in crime science, we believe that crime happens because there are three reasons, right? Three things that happen at the same time. First, there has to be something to steal, right? Somebody is like the victim, there is some property, there is something to steal. In the middle of the desert, there is no crime because there's nothing to steal. In the center of the city, there is a lot of things to steal, so there has to be something, right? Then there has to be somebody motivated to do the crime. And third, there has to be an opportunity. That means every time there is interactions between criminals and victims, these interactions happen on a daily basis, but there is not always a crime because there is not always the opportunity. And what do we mean by opportunity? Something like this. Either a parking lot, an empty space, the metro station, under the bridge, whatever you think there's an opportunity, there's no police, there's too many people, there's too many whatever. That is opportunities. And opportunities, the important thing is that they repeat. If there was an opportunity today for a crime to happen, then almost the same will happen tomorrow, right? That means, in principle, we can use crimes from the past to look at crimes of the future, right? It's not just data-driven. This has a crime science motivation, that is the opportunities are repeating because the patterns will be similar. And so let's talk about the opportunities. I don't care much about the victims because there's 30 million people. And I don't care much about the actual criminals because there are too many and we don't know who they look like, right? We don't know exactly who they are. But we can talk about the opportunities. And that means opportunities, imagine them on a map. I put in a map of Mexico City a dot in every single crime by different types of crime, and red is robbery of a person. That means somebody take your phone, take your wallet or something. And you can tell that there is a very clear spatial pattern. Like here, that is a metro station inside Mexico City that obviously, because there is this metro station, Metro Hidalgo, then it gets super crowded and therefore you have a lot of crimes in there, right? However, there is this neighborhood, it's super beautiful, by the way, because that's where I live. And there's almost no crime in there, right? So you can tell that there are spatial patterns. You can clearly identify avenues. You can say, this is more robbery of a person. This is more a pedestrian neighborhood in Mexico City. Whereas this is more like a commercial neighborhood because there is almost no robbery of a person, but there's other types of crime, right? Based on that, you can do some math. For instance, look at where would you put the police, right? So that's a quantitative question based on crime, You assume that crimes from the past are crimes from tomorrow. If I give you the crimes, then you can sort of think of where to put the police. That question is called policing. How's the policing strategy? Where do you put them? And the idea, we can transfer this question into some math equation. Let's get the Voronoi polygon, let's say. And the Voronoi polygon means wherever there's a police, the closest police will be the one that attends the emergency, right? So if I get a 911 call, I will get anywhere here. The police that will react is this one. But if there's a 911 call here, the police that will react is this one, right? Then I simulate hundreds or thousands or millions of crimes. And then I get, based on the police, the expected time for reaction, right? So I measure if there was a crime here, how long will the police take from going from here to here? I measure that. And the objective now is to minimize attention reaction, right? Or the time that will elapse between you call 911 and the police gets there, right? Now, I know that this sounds simple, but there are many actually issues here just on the quantitative part. Minimize reaction time means for every call, imagine a matrix with like hundreds of calls that you simulated, you get expected reaction time, and you want to minimize that vector. But what do you want to minimize? The average? The average is okay, but then it means that for some calls, the reaction time might be 60 minutes, especially on the outer parts of the city. You minimize the average of this vector, but then for some of those that happen very rarely, very on the outskirts of the city, your reaction time might be too huge, right? So, okay, you want to minimize the maximum time. You want to minimize the average with restrictions so that you don't take more than 60 minutes to react or something like that. It's not so easy, it's not a trivial question, and it's philosophical, because obviously the ones that live in the dense part area of the city that you're minimizing and that you're saying, hey, the police will be there in 1 minute, those are the wealthy. Whereas those that live in the outer parts of the city and where you will react in 60 minutes, those are the impoverished neighborhoods, right? So when you minimize just the average, you are just actually putting a lot of privilege in the already privileged people, right? So it's not so easy. There's an ethical dilemma here that is, where do I want to minimize? And actually thinking of those that live in the other parts of the city becomes a tricky question. But then we can do something else. Imagine that you have all the crimes. For every crime, then it's like a 3D surface, right? In the surface, I have all the reported crimes. And then I put some kernel density in 2D, so it looks like a mountain. If I add all of those mountains, then it looks something like this. You see that those two crimes are closer, so therefore this sort of mountain is higher. If I do that for, and now in the bottom part is Mexico City, actually. You see here is the airport, and here is a forest. This is all the crimes reported to the police in Mexico City in 2018, I think is the year. You do a kernel density, looks like that surface. If I see it from above, it looks like this. Again, the airport is here, and the forest, right? This just is shiny because I used R to make it like super shiny, but if we remove that effect, then it looks something like this, and this is the hotspot map that the police uses, right? Again, the airport on the right-hand side. Actually, it looks more something like this. This is the product that we give to the police, and you can tell there is a clear spatial pattern, right? But it's rooted, again, in crime science. Patterns repeat because opportunities repeat. And you can identify very congested avenues. The north-south insurgentes, metro stations, a market, neighborhoods that are very crowded. And it's interesting because if you show this map to anyone that knows Mexico City, they will think awful and very crimey patterns and maybe safe and beautiful. And it is not true, actually. These are the most touristic, beautiful parts of Mexico City. What you're observing there is the density of people as well, right? So you have, where there's more people, there's more crime, basically. And that's what this map is telling you. If you want to get the risk, where do you think you are safer in Mexico City? Here or here? Well, actually, here, there's hundreds of thousands of people passing by every single day. So when I take the number of crimes and I divide by the number of people, your risk is close to 0. Whereas here, almost nobody lives, and there's one crime, but for that person that lives there, right? So actually, individual risk is much higher in the southern part of Mexico City than in the center. It's just this is congested Mexico City, right? Anyway, based on this, we can actually get some strategy, and that's what we do with the police. And there are many interesting questions to look at in terms of the place of crime, right? Now let's talk about the time of crime. Similar idea. Let's get when the crime happened. And if I get you the time where crime happened, now you'll see some super interesting technique. I get you crimes. I put a kernel. When there are too many crimes, the kernel gets higher. And there's just one trick, very simple, that I did here, is that after Sunday comes the Monday, right? It's very obvious, but I don't think it's so trivial, because then this crime that happened here carries on until the mountain that you see this, okay? So we're going to look at the time of the week of crimes, right? Those are the crimes simulated. That's the heartbeat of where crimes would be. But if I get all of the crimes in Mexico City, these are 200,000 crimes. This is the actual heartbeat. And we call it the heartbeat because it actually looks like one of those echograms when you go to the doctor, boop, boop, right? And this is actual data from 0 to 1, the maximum density. And you can tell there's Monday with a peak during lunchtime, with a peak after people go to work. That is exactly the same on Tuesday, Wednesday, and Thursday a bit, but then Friday, you see? Higher than the rest of the days, peak much higher than the rest of the days. And when it goes down, it doesn't go down as much as in the other days of the week. Because people party, right? Because you go out and you drink, and then because people party, then this valley is not as low as in the other valleys of the day. Saturday and Sunday is super different because criminals, they also take break, right? I mean, it's true. But this is in the day of the week. We can actually plot it on a clock. And in a clock, it looks like this. Now, I know that clocks, they have two roundabouts in a single day, right? I don't know why. Some stupid person decided that in a day, in a clock, you're going to go twice around the same moment, which I think is the stupidest decision ever. Wouldn't it be better a clock that only goes around once, like this? You start when the day starts, and then by midday you're here, and then by the end of the day you're here. This, for me, makes much more sense. Why 4 a.m. it's matched with 4 p.m. Anyway, in this clock, you start on a Monday, that is this purple, and the outer you are, it means more intense in terms of crime, and the closer you are to the center, it means less intense in terms of crime, right? This is exactly the same data as here. This is just plotting that sort of pattern on the clock, right? And you see, we start in a Monday with this purple, and on a Monday, you go out in intensity, and by midday in Monday, you're here, and then night of a Monday, and then you go around to Tuesday, right? And then Wednesday, and then Thursday, and so on. Now, some super interesting patterns that you can see here is first Friday. Friday is this orange, and you can tell that by midday on Friday, actually Friday gets much more intense than the other times of the week, much higher actually. By 10 p.m. or 8 p.m. on a Friday, we have the highest crime intensity in Mexico City, and it is a nightmare. Being in 911 and receiving so many emergency calls Friday at 10 p.m. in Mexico City, it is really, truly a nightmare. You can tell the pattern that forms Saturday, much lower. That means less intensity than other days of the week because it's a Saturday. Less intense also on a Sunday. And then you begin again the week, right? Something super interesting, because this display actually tells you like how the pattern is that you can tell that Monday at 8 a.m. is more intense, much more than the other days of the week, right? Like 20% more. Because criminals, and we believe that criminals over the weekend, they need to compensate and they feel guilty for not working. So then they go on a Monday morning and they are like productive. So then they go and increase the crime intensity Mondays at 8 a.m. And then the rest of the days, they look basically the same, right? Now looking at the crime like this, tells you like when do you need more resources, when do you need less resources, or even where to allocate them. So this is the map of Mexico City, again, with crime intensity, but we can look at the heartbeat by location. right? So imagine that I take Mexico City, I divide it into 200 neighborhoods, and for each neighborhood, I give you the heartbeat. The crime heartbeat for each neighborhood now looks like this. Something super important. Who is a physicist here? Everybody, perfect. Thank you so much. I'm not. So physicists, they love claiming something like, oh, this is universal. It's not universal at all. Actually, the heartbeat is extremely different for every single neighborhood. And you can tell that there are neighborhoods that get extremely crimey on a Saturday, not so crimey in the rest of the days. That is, crimes that are happening between different neighborhoods. You can tell that there are some that get very busy Monday morning, some that get very busy on the peak on the Thursday. Obviously, because there are neighborhoods with a market and neighborhoods with a concert venue, some are offices, some are schools. So whenever I hear a physicist claiming universality, I tend to laugh a bit because it's nothing in society will be universal, not for cities, not for scaling, not for crime, not for anything. Especially here, like you can tell, like it's super heterogeneous, right? The only pattern is that it repeats throughout the week. You will see roughly the same pattern. Now with this, we can actually tell, okay, where is the pattern happening in different neighborhoods in Mexico City? So you have a congested neighborhood here that has a lot of services. That means restaurants, bars, venues, etc., shopping areas, or a neighborhood that has a lot of schools that is in the south. This is UNAM. UNAM is a university in Mexico City with 375,000 students. I think just this university has more people than Palma. So, of course, here you have a lot of people that create a lot of crime or suffer a lot of crime. It's not because the students create crime. It's that they suffer crime is more people when the university is open, right? So because of that, there is a specific pattern for university city, for the places where you have a lot of bars and restaurants, for the place where everybody's working, for the hospitals. So this pattern actually tells you that there is a relation between the crime heartbeat and the land use. Not even that. Based on the idea that with the land use, I can tell you the heartbeat of the city, we have used the same pattern that you observe here. So this is the concert venue, because obviously Saturday you have concerts, and therefore when people go and come back from the concert venue, there's more crime. So we can tell you for crimes in Guadalajara, in a different city from Mexico, what the heartbeat will be based on the land use. So tell me where is the market in Guadalajara, and I will tell you when the crimes will be. Tell me where is the venue in Guadalajara, and I will tell you when the crimes will be, right? So even without knowing the temporal pattern in other cities, we try to look at when the crime will happen in other cities, right? So we use that, and actually something super interesting is precisely the venue of concerts. This is Velódromo. Velódromo has two major venues for concerts, including Foro Sol and Palacio de los Deportes. Almost every Saturday, there is a concert with 40,000 people. And you can tell, yeah, there is the venue, and that is the heartbeat from Saturday to Sunday on Velódromo, when there is a concert and a lot of people, right? The only time I suffered a crime in my life was actually leaving a concert in Velódromo, exactly like Saturday at midnight. So I was one of these people, by the way. Condesa is where my mom lives. And in Condesa, you see like a very different pattern that is where more elderly people live, like my mom. So there is not much happening in a Saturday. So people tend to stay at home because the people tend to stay at home. There is not much crime, right? So you can tell that there are crucial differences. And with that, you can actually try to understand where to put your police and where to move them, right? There are optimization problems here. For instance, where would you put your police? Here, yes, here in the morning, but here in the afternoon. Yeah, but people cannot move so easily between one place and the other. So the optimization is not so trivial because it has a cost. So minimizing transportation costs or time to react is super interesting to look at it based on these heartbeats, okay? Or even correlated to land use, as I said, here something I found fantastic is G is one heartbeat. This is the pattern. And we cluster different heartbeats. G in the center, F is the financial district, D that is a bit in the outer parts, and so on. And we notice that if we cluster heartbeats based on the temporal pattern, and if we cluster neighborhoods based on the land use, actually the clustering is too similar. That is super interesting for me because it means, yes, the heartbeats of crime and the land use of the neighborhood is actually telling you similar amounts of information, right? That means you can tell residential parts, suburban areas like C or B, they tend to have this temporal pattern. Whereas in the center, you have this temporal pattern, right? That's basically the idea. Let's look at the different types of businesses or shops that you have in a city, and then I can tell you how will crime occur, right? There is a paper, there are some papers here on the heartbeat, and I think it's super interesting to look at. Now, changing topic for a bit, because I think in IFISC, this is a super relevant topic. Maxi, I know that this is like your area of research as well. Let's talk about opinions of crime, right? Why opinions? Well, I finished my life in the police department, and I left with the conscious that one thing is crime, very relevant, what we do in the police, and a very different thing is fear of crime. For me, those are two different things. And in terms of crime, we can measure, those are the number of crimes, those are like how many victims you have. And let's suppose that we can quantify the number of crimes. It's somehow reasonable. More murders, more victims, more people, more, yeah, crime, right? And let's put that in the horizontal axis, less crime and more crime, and we are here. It can be a city, a neighborhood, today, whatever, the amount of crime in the horizontal axis, right? And let's put in the vertical axis, fear of crime. People feeling more secure and people feeling more insecure. Usually, on the horizontal axis, you can measure it with victimization surveys. How many crimes did you suffer last year and so on, and that's the metric in the horizontal. And in the vertical axis, usually people ask, how safe do you feel when you walk alone at night? And they give you some answer, very fearful, somehow fearful, very secure, not insecure. If you mesh those, then you get a measurement of fear of crime in Mexico City, or a measurement of fear of crime in the neighborhood, or in the region, or in the region in time, right? So like the idea is just who feels afraid, and you merge that, and you get some metric of fear of crime. Right? In my experience in the police, we were somewhere in terms of crime, and somewhere in terms of fear of crime, some unit, okay? And we expect some sort of relation. I'm not sure it's linear, obviously it's not linear, it doesn't matter, but the expectation is that if I have more crime, then people should be more afraid, somewhere around here. And if I have less crime, people should have less fear, right? That's the expectation, that if I control crime, I can control fear of crime. That's what we expected, but then 5 years in the police for us was like this. People started feeling, even when we reduced the number of crimes, people start feeling more and more insecure. But we actually decreased the number of crimes by half in Mexico City. And even if you reduce the number of crimes by half, you still have people that felt more insecure. For me, that was a puzzle. I wanted to answer this, and that became my PhD. So my PhD is this topic, okay? And let me show you a bit the idea that we want to measure what is fear of crime and how is it related to the actual number of crimes in the city, okay? The idea actually happens not only for Mexico City and how fearful is Mexico City, but if we compare 32 cities in Mexico, the same happens. You have cities with a lot of crime that feel somehow secure, or cities with almost no crime that feel super insecure. So when you compare between different regions, you can tell that actually fear of crime is a totally different social construct than the actual number of crimes. And we try with different types of crime, we try with different sort of media, we try with many models to understand if there was a relation. And the answer for me is not so much. And why? Complex systems for me. That's why I'm very happy to be talking about this here. I think this is an opinion. And why an opinion? Let's suppose that I measure fear of crime from being very secure in green to being very insecure in red. And I put a network with people talking to each other, right? Like every model of opinions that we have. And let's suppose that there's a person there that suffered a crime. They got the wallet stolen or something like that. And they share their opinion. This is insecure with the neighbors and with the peers and with the family. And they suffer second-hand victimization. Second-hand victimization means you don't actually suffer crime, but you are close to somebody that suffered a crime, so you feel somehow insecure, and you pass that opinion to others, right? More insecure, and they pass it. And then eventually it gets dissolved in the network because there's not much. But if there was a second crime, they also share the crime and they also share the perception. Then I get from this, I ask everybody, how afraid do you feel when you walk alone at night? And I get an average measure of fear, right? That's precisely the model of opinion dynamics. I get two crimes, they distribute their opinions, and then I ask them, how afraid do they feel? But then what happens, and this is the most interesting part for me in terms of crime, what happens if the second victim, instead of being here, I put it there? Well, this person tells the neighbors, hey, this is insecure. And they are like, yeah, but I knew, right? Because I knew, not really. This is the only change. And then this second-hand victimization happens with people that already had second-hand victimization. So when they're past their fear, well, yes, and then I measure the amount of fear. If I compare these two societies, you see two crimes and two crimes, same topology, same distribution, same everything. I'm just changing where the crime happened. And just because I change the crime from here to there, I can get a safer city, right? Or at least safer in terms of perception. And this is, for me, one of the most relevant things of what happens with fear of crime. So let's model it. Let's think of a population in Mexico City, let's say, and I sort every person in Mexico City based on the number of crimes they expect to suffer, right? This person expects to suffer 0 crimes, 0, 0, 0, 0, 0, and this is like 10 million people. And then I have 9 million people that expect to suffer some amount of crime. This is the number of crimes that they expect to suffer in a year. And then as with every social process, you have concentration. That means a small amount of people that suffer a lot of crime, right? Yeah. This is called a victimization profile that tells you how many crimes would they expect to suffer in a single year. And this lambda rate means these poor people, they suffer a crime every single month. They suffer a crime every year. They suffer no crime, right? Then based on that, which by the way, you can follow on the victimization profiles in a super interesting paper, we actually constructed this based on actual data from Mexico City. And based on that, we can divide population into different groups. A rate of 0.05 means that you expect to suffer a crime every 20 years. It's super small victimization. A rate of 1.7 means that you expect to suffer a crime every like 7 months. So this is super intense victimization, right? The difference is huge between those two rates. And then a group that doesn't suffer crime, rate 0, this is like they are immune to suffering crime, right? Then based on that, we simulate the opinions in time. How afraid do they feel? And what this model tells you is some dynamics. First, those that suffered a crime, and we assume that when you suffer a crime, you get a lot of fear. Then those that have social interactions, it means you go and you tell your neighbors or your friends, hey, this is insecure, right? So social interaction, they got a social interaction with somebody that has more fear. They had a social interaction with somebody that has more fear. And we get that. You can have also social interactions with somebody that has less fear. So if somebody has less fear, they tell you, no, no worries. He's not so insecure. And there is some consensus in terms of opinions here. And finally, we got some memory decay. And we simulate hundreds of crimes, right? Actually, thousands, millions of crimes. the result is something like this. After we get for the blue group that is not suffering a crime, they are actually immune to crime because I simulated, right? Those people, they get fear just because they get social interactions with people that suffer crime. Red suffers crime, but rarely, and green suffers a lot of crime. Then we measure the average distribution, the distribution and the average amount of fear from super secure to super insecure. And green are those that suffer a lot of crime. Blue are those that will never suffer crime, right? And the interesting part is that by simulating this dynamic with some topology in the network and so on, I get to simulate the idea that yes, there is some people, the blue, that have some fear, even though they never expect to suffer a crime, different to those that suffer a lot of crime, right? This was natural. Now the interesting bit is that those that are immune to suffering crime, they still get some fear. Now, here, then I can actually take the victimization profile and double the amount of crime or divide it by 2, right? Now, double the amount of crime is this person that suffers 0 crimes. Let's multiply it by 2. 0 by 2 is 0. 0.05, this person that suffers 0.05 crimes multiplied by 2 is 0.1. And this person that suffers a rate of 1.7 times 2 is 3.4, right? And the same if I divide it by half, 0 divided by half is 0, 0.05, and 1.7 divided by 2, right? So it's just the same profile, I inflate it or I deflate it. And this is, for me, the most interesting result of my PhD. I know it doesn't seem impressive, but look at this. I take the amount of crime in Mexico City, and I increase the number of crimes by 2, and nobody noticed. Almost nobody noticed, right? Those in blue, they are immune to suffering crime, so then they don't realize. Those in green, they already had a lot of fear, they suffer more and more crime, but they already have fear, so then they don't notice. I actually can do the same in the other direction, decrease the number of crimes by half, and those that don't suffer crime, they don't realize, because they are suffering less crimes, but they are the same as they were. And those that suffer more crime, they do get some improvement in their perception, but they are such a small minority that we don't realize either. So for me, this is precisely the idea that when I get the average amount of fear in a city, even if I multiply the number of crimes by 2 or by half, the average fear of crime in Mexico City will be basically the same. Now, when I got this figure, I knew I have a PhD. This was the result from my career, from my PhD, because I knew what I was here to actually understand. Fear of crime, this was for me the figure, and I knew, I think I got it. Now I can defend the story on why fear of crime behaves the way it behaves, and why in Mexico City, in the police department, we take the number of crimes, we vary the number of crimes, and the average fear remains the same. Sorry, can you repeat?
What happens with what ethical access to logarithmic scale? Perception of many things is logarithmic. You have 1 gram and another one is 10%. You have 1,000 grams and 2.1 is 0.1%. So perception of growth is usually logarithmic.
Okay.
So would you both know about that it is something related to the perception? That the perception is with the logarithm, with the rate of change, not with the change.
Yeah. I know what you mean, like the law that an increase of 10% is significant.
I mean,
yeah.
Everything that is a perception compared to what you have is usually relative to the size of whatever you have.
Definitely. Just for the notice here, I didn't, well, the people are simulated here. So for me, it was just a simplistic dynamic for understanding the actual process of fear of crime and how it gets distributed. I think if we stretch the axis in a different way, then you would get something between -infinity and infinity or something like that, or -infinity and 0. You can distort the story, right? But for me, the mechanic was trying to understand why you can increase crime and perceptions remain almost the same. Okay, I understand that an increase of 10% in the number of crimes here will get you some difference, but I think the result would be roughly the same. And the point is this, if you want to reduce the number of crimes for the people in the city to actually be aware that there is less crime, you need to have a huge reduction. Like only when you reduce to like 10% of the number of crimes in Mexico City, you will actually get now people feel safe, right? But I agree that there are logarithmic rules.
So you actually said that you expected this to be a linear relationship in Mexico. You didn't get that, but in other cities, I mean, when you compare across other cities, you do get this increase. So I mean, there must be something here, which I suppose it's Group 1 being immune, something to do with heterogeneity in the space, no, and in the mixing of opinions. I mean, how do you then explain with this kind of argument or mechanism the other patterns you see?
Jesus, that's a fantastic question. But let me give you the next figure, right? This is the story. Okay, now I want to see how people mixing actually alters the opinions of people. And you see, you can have more homophily, that means people that interact mostly with their peers, or less homophily, right? That people reject to interact with people like themselves. And now the idea is we have this level of homophily with this level of fear in average for every single group. Remember blue? Those that never suffer crime, right? Blue is immune to suffering crime. And as you were asking, Jesus, precisely, if I get more homophilic groups, then those that are blue, that are immune to suffering crime, they start interacting with people that are also immune to suffering crime with a lot of homophily, then they actually get super secure because they become unaware of crime. Those that suffer a lot of crime interact with only those that suffer a lot of crime, so they become more fearful. And then the average is almost like the pink one, right? Now this tells you the worst that can happen to your city is having less homophily in terms of fear of crime. Is the result from the agents that I simulated on the opinions. Right? So this, we start with the opinions on the network. Sorry, I had to go back a few, like this. I simulated a network with, I think, 20,000 individuals with an initial opinion. I let them burn for like 1 year. And then after that, they get a stable distribution on their amount of perception. With that, I measure the average, the distribution and the average per each group. And then I took different simulations of more and less crime and more and less homophily, okay? Now here, the policy is super disgusting, I think, because it means if you want to increase the level of security in your city, you have, remember, the blue group is huge and they are immune to suffering crime. And if you increase the segregation in your city, then you will get an improvement in the perception, right? It's super disgusting, eh? Don't tell this to the police because they want to do this. That those that suffer crime, they get segregated because then they share their opinions only with those victims, but that's a small part of the city. So that will improve the perception. It's not politically correct, but this is one way to improve the opinions of your city.
What happens when the media is telling all the time that there is a lot of crime?
Media, right? For me, media is a super relevant topic. Now, the only issue is what is the result of media? And I was not expecting having to do research in terms of media, but for defending fear of crime, I actually ended up doing research on media. And it's super interesting because what is the impact that a crimey item in the news gets on the people? And I was expecting that more crime news in the media means more afraid, right? More fear. And it turns out that research actually is quite contradicting in this area, because when you read, there was a crime happening in the downtown of Mexico City, there are many things that the reader gets. First, if I never traveled to Mexico City downtown, maybe I don't care. Second, was there an arrest? The police arrested a criminal in Mexico City. Well, some people understand there is one less criminal in the street, so it's better.
Well, because, this, opinion, the opinion article in the newspaper telling there is a lot of crime,
Mhm.
which is abstract. There is a lot of crime in Mexico.
For the let me go from top to bottom. Sorry, from bottom to top. When the news are specific, like there was a rape or something in Mexico City, some researchers argue that as long as the reader cannot identify themselves or their peers with the victim that is discussed, then the impact is negligible. Second, some research suggests that the media is a self-selective process. So when you read a newspaper, you already have an inclination of what you're expecting to read here. And you have some newspapers like The Guardian that will tell you some type of news, and you have Fox News. And if you open Fox News, you already are self-selected to read this sort of media, right? Because of that, most of the research today shows, in a way, because it's social research, so it's not so transparent, that, I mean, it's true, no? It's not physics, it's not like a fixed social news, so it's tricky to measure. That the impact of media for some people is positive and for some people is negative in terms of crimey items. So that's why media is not included in the model, because it's too tricky to try to put media or social media in the model, okay?
Take the blue group.
Uh-huh.
Blue doesn't suffer crime, but they watch Fox. So they are correlated.
Yeah.
Okay, and since they watch Fox, they listen that there is a lot of crime, and as a consequence, they believe that there is.
Yeah, exactly. So it's second-hand victimization, the one that we are discussing, right? This second-hand victimization means you get either with a direct victim or based on media or social media, how the perception is. I didn't bring that paper here, I think. This is the paper that I model the perceptions of people. In a separate paper, we tried to look at opinions of crime and fear of crime in social media. We downloaded 35 million tweets from Latin America, and we tried to understand how correlated this is to actual opinions of crime in social media. And the correlation for us was close to zero. That means those cities in Mexico City that have more fear, they don't talk more about crime in social media. Then media is maybe sometimes very distant. So you're in Palma and you hear of a crime that happened maybe in Valencia, and then you still get some perception of fear because the crime reminds you that crime happens there. So I know media and social media here is tricky. And if you're interested in doing that research, I think we can work together on that topic. We had to stay away from media and social media because really it was complicated on the perceptions of people. Any other question related to media and social media? Perfect, because then I move to the last topic, networks, right? I have, what, like 10 minutes? Perfect. I will finish. Okay, because for networks, let me just give you the idea. I will talk about cartels, and cartels in Mexico are today the biggest issue that we suffer in Latin America and in Mexico specifically. And a cartel is something like this. You're talking about an actual army with weapons, with presence in the media. It looks like an actual army. And this is today the biggest cartel we have in Mexico, called Cartel Jalisco Nueva Generación. It looks like this. And for me, it's extremely scary to look at a cartel from Mexico, right? This is the actual issue. And like Latin America, today is suffering a lot of crime. These are the murder rates in some selected countries. And I brought Austria because I'm living in Vienna, compared to Mexico, right? And this is the murder rate, so I can compare number of murders per 100,000 people, and you can tell we are not in the right track. Latin America today is actually a lot of crime, right? if we compare in terms of time, from 1990, the year I was born, up until 2020, well, crime was actually being reduced. This is homicides per 100, a record of 8.3 in 2007. And then we did something wrong. And this something wrong, if anyone knows something about Mexico, is that we started fighting cartels, mostly because somebody in the US decided we had to. So we started fighting cartels because their health and drug addiction problem had to become a security issue in Mexico. So we had, ever since 2006, 3 presidents, one in 2006 to 2012, Felipe Calderón, fighting crime. Then the second, 2012 to 2018, Peña Nieto, fighting crime. We're doing it. And then the last one that finally is finishing, López Obrador, from 2018 to 2024, fighting crime as well. And we are just failing, right? And for the 3 guys, Peña Nieto, López Obrador, and Felipe Calderón, I have listened to them saying, every time there is a murder, no worries, this is just cartel against cartel. They are ajuste de cuentas. That means they are just checking each other out, right? And when there is a huge murder, and by huge, I mean 40 people, 20 people, like murders, right? The army size. Those 2 presidents, they claim the same stupid thing. No worries, they are just in ajuste de cuentas. And for me, that idea was super tricky because, okay, for the first guy, I thought, okay, ajuste de cuentas. If you think about it, in a city, when there's ajuste de cuentas, you have some criminals fighting some criminals, they have ajuste de cuentas, and some criminals die. So therefore, tomorrow, there should be less criminals, right? So if they keep ajuste de cuentas, eventually they will just finish the number of criminals that we have in the city. So I was growing up with that idea that eventually if they ajustan, they finally have the cuentas. Yeah, it's true, like there should be no more crime, right? But something doesn't work with that. And I want to show you quickly what doesn't work. So for cartels, we don't know almost anything because there is no census of cartels. We don't count. There's no survey. Are you part of Cartel Jalisco? Are you part? Have you been engaged? So that doesn't happen, right? But what we know from cartels are 2 things. First is the number of homicides, basically that data that I show you. I can see the number of homicides in Mexico, and I can sort of count the number of people that we arrest, right? And that's basically it. We don't have more things in Mexico, but those 2 time series. And based on that, I wanted to model that idea from the presidents of Mexico, that there is ajuste de cuentas. So I'm going to model cartels like a node in a network, where the size represents their size, the number of members. And we model reasons why cartels grow, or reasons why cartels, they shrink, right? They shrink. And we say, okay, a cartel grows because they recruit new members, or they shrink because they fight, sorry, no. Incapacitation is the police. Incapacitation means arrests. Just a crime scientist here corrected my language, and we cannot say arrest, but it's incapacitation. And they lose this slice of pizza. They get maturity, that means they fight with each other, so they shrink, and that's maturity. And they fight with each other, and because of that, some cartels lose some members, right? So the model I will present is as simple as that. Cartels, they change in size because they recruit, and that's why they grow, or because they fight against each other, they lose members, or because they have maturity, they lose members, or because we arrest them and they lose members. 4 things, one of them is growing, the rest is negative, right? Now that, we actually got some data from social media, called Bacrim. These are newspaper items that whenever there is a cartel appearing in the same news item with another cartel, they register that. They register that there are 150 active cartels in Mexico. And whenever they fight, we put an edge between those 2 cartels, right? This is a whole universe. If in the news item, they appear to work together, there is an alliance, and we put an edge in the alliance, right? Combining those 2, now we can show Mexico's radiography of cartels basically are one big cartel, here called Cartel Jalisco, and all its satellite cartels collaborating with Cartel Jalisco, fighting a lot with this cartel called La Nueva Familia Michoacana, and fighting a lot with this cartel called Cartel Sinaloa, and all its satellite cartels, right? That's basically the radiography today of cartels in Mexico. And now let's combine that idea of cartels grow because they recruit, we arrest them, they have maturity, or they fight, with this network of how they fight, and that gives you differential equations, right? Cartels grow because they get recruited, we arrest them, they fight, or they have maturity. For each cartel, we have a differential equation. They are coupled because you need the size of cartels to solve the size of another cartel. And after solving them with some initial conditions, we got an interesting paper that just got published a few months ago with some results that were a bit controversial. So I've been in the news a lot since the past few months. And CNN, including Fox News, obviously, I had to be in Fox News. In El País, actually, I appeared quite a few times. In BBC, in The Guardian, even in The Economist, we were. And maybe the biggest honor we have is that the president of Mexico discussed my research. This is the president of Mexico, and that is me on Twitter. And he called me, instead of scientist, mathematician, thank you for working for those, he called me a traitor, imbecile, liar, cheater, and trying to demote his government. So that's why I'm very happy that we only have 2 months of this person being the president of Mexico. But anyway, let me tell you the results, right? Because the results are the interesting part. First is that we try to model the number of cartel members, and the number of cartel members, it gives you the following. In Mexico, we have 175,000 cartel members. And obviously, the president of Mexico didn't like that number, right? Obviously. What is 175,000 cartel members? Where in Mexico, the top employee is Coca-Cola with 321,000 members. The second is Walmart. The third is Manpower. The fourth is América Móvil, a phone company. And then cartels are the 5th biggest recruiter in Mexico. Obviously, when you say cartels are the 5th biggest recruiter in Mexico, you get the cover in Fox News. And then the rest of companies, right? That's why the result became quite controversial because, well, what do you mean cartels are the 5th biggest employer, right? And I had to explain this result many times, but that's one of the results that are huge.
It's not correct.
No, there is no census.
Obviously, because
By trying to solve the differential equations for the input data that we have, that is homicides and arrests for 10 years of input data, that is 520 weeks on weekly intervals. And this is the best estimate that we have between 160 and 185,000 members. After we publish the number, DEA, La DEA, from the United States, they actually published a report saying like, yes, we believe this number is correct. So we are feeling confident about that. Let me quickly give you interesting results because the number is just for me a sort of trivia question, right? What do you do with this number? But let me give you some results. This is a system of differential equations, so I can look at it in a differential equation way. And this means, imagine one cartel and the police, and this is the size of a cartel, right? Very big number of cartel members, very small number of cartel members. And if in the system you have a very small recruitment, then the arrows tells you where the dynamic is going to move. So if I start here, the police finally will be able to dissolve, will dissolve the cartels, right? For a small recruitment, and this for me is Austria, it doesn't matter how big the cartel is. The police always finish with the cartel. The police is always capable of reducing cartels. With medium recruitment, you have one interesting node that is an equilibrium node, where you have that the cartel recruits 10 members, but the police arrest 10 members. And every week they recruit them, but they arrest them. So then they are in equilibrium. But this equilibrium is unstable, or is stable only from the right-hand side. That means if you start here, you finish in this node. But if there is a small departure, then eventually the police will be able to dissolve them. That's with a specific amount of recruitment. But with huge recruitment, now there's a new area. And this is the interesting bit. Now you see the arrows point in this direction. Between here and here, you form a new region. That is a region where the cartels actually here, they recruit 10 members and the police arrest 9. So 1 week later, the police actually is arresting a lot of cartel members, 9 of them, but the cartel is growing, right? So 1 week later, they recruit 10, but they arrest 9. They recruit 10, but they arrest only 9. And because of that, the cartel actually is growing. This is like a stable node that forms like a valley, where if you have a football, and if you kick it to this side, it doesn't matter because it comes back. But if you kick it to this side, it also comes back. This is a equilibrium node. And actually in this region, cartels are growing. Even if you are arresting a lot of people, even if you as your police is arresting a lot of members, you have this new regime where is either cartels will be here or with fluctuations. Okay, you can have fluctuations. Or if your police manages to dissolve a lot and jump over the other side of the mountain, then you can destroy them, right? So for me, this is Austria, where the police is capable of reducing every single cartel member. And this is Latin America. We have cartels here. Sometimes they increase in size, but the police returns them. Sometimes they lose members, but they recruit members, and they are permanently around that north. And even in Colombia, Ecuador, Mexico, or Nicaragua, Honduras, and El Salvador, we move a lot, but we are in this very stable situation, right? And this is one cartel against the police, so that's why we cannot. And let me give you the second. What happens when you have 2 cartels? So this is one cartel, Jalisco, versus the other cartel, Sinaloa. The arrow tells you where the dynamic moves to. With small recruitment, the arrow tells you they will finish, right? And you start in a green node, and then it takes you to the yellow node. That means with a small recruitment, again, in Austria, the police always manages to dissolve all cartels. With medium recruitment, now you have a different regime. Here, you begin, cartels are fighting, police is arresting, but then eventually you finish here, where now the police cannot dissolve them anymore, right? And this is with some medium level of recruitment. Here, and this is super interesting, although disgusting, here the police can dissolve cartels because they are using the conflict between them, right? And because they kill each other, then actually you can finish in some peaceful state. So sometimes you want them to kill each other. This is ajuste de cuentas for me. Well, okay, they ajusta de cuentas and they finish. However, with a large level of recruitment, now that region doesn't even exist. Well, it exists here. Here, if there are so small number of cartel members, yes, we will eventually dissolve them. But anywhere else, if you start here, you finish with a high number of cartel Sinaloa. If you start here, you finish with a large number of cartel Jalisco, and that's it. The rest is one stable node here, one stable node here, and one stable node here. The dynamic is only having those three stable nodes, right? And for me, this is the story of Latin America. Not only that, on the system, we can push time ahead, and so that's what we did. This is Mexico in 2012, based on the numbers. This is Mexico in 2022. And the vertical axis is the number of casualties that we have in the country, right? In our model, we can tell that the number of homicides in Mexico is increasing a lot. That's what this model tells you. Remember that it's just looking at it from far away, right? There are fluctuations, but this is the model part. And then we push 5 years ahead. If I push 5 years ahead, using what we have today, well, Mexico, we are condemned. Eh? This is terrible. If we follow the same as we're doing today, Mexico is going to become like a war zone, even more so than it is today. But then I can do something, right? And that is what mathematics is about, or complex systems is about. So that's what I tried. And I changed parameters. What happens if we increase the number of arrests? Well, if we increase the number of arrests, no, doesn't work again. With double the number of arrests as today, we will have more homicides than today. It's flat now, almost flat, but more homicides than we have today. For me, again, this is a personal story, right? The day I got this result, I had to close my laptop and go for a walk in Vienna because for me, this is extremely depressing. Tells you Latin America is extremely violent. And even if we arrest twice the number of criminals, we'll be even more violent in the next 5 years. This is doomed. Let's try another parameter because I can adjust parameters in the model. Let's try reducing recruitment. And I reduce the recruitment by half. That parameter in which they keep pushing people into the cartels. If I manage to recruit half, Mexico then will be less violent than today, but more violent than 2012. I can, as a mathematician, push it to the corner. If the recruitment is equals to 0, then we still have less violence than today because the cartels are just shrinking, less homicides than in 2012. But even if recruitment is 0 in Mexico, we will be more violent than any country in Europe in 5 years. That's Mexico today. And the result obviously is extremely disgruntling as a Mexican. And I know that, well, this is how the panorama will look. Even with recruitment equals to 0, in the next 5 years, Mexico will be still violent, right? And just food for the thought, why is this what that we're observing? Well, one of the reasons is this, that how much are we investing in security? These are countries from the OECD. Vertical axis is how much are we willing to invest in security. And you see the average is 1.7, 1.8% of the GDP gets invested in security. And today Mexico is investing 0.6. We are not investing enough in security. And that's basically what this result is telling you is, yeah, it's very complicated. You see countries that invest similar to Mexico for fighting violence are Ireland, Denmark, Finland, Japan, South Korea, countries that have no violence, right? Countries that have similar level of violence to Mexico, Colombia, well, Costa Rica and Colombia, that is somewhere there, here. Colombia invests more than 2%, so 3 times the amount of budget in fighting insecurity is what is invested in Colombia than in Mexico. And this was just to conclude because I think it's time just to show you a bit how I think that complex systems can help us understand patterns in terms of crime, in terms of where crime happens, in terms of opinions of crime, media and crime, or as I show you here, violence and cartels in Mexico. Thank you so much for your time.
Thank you very much for a very, very nice, interesting talk. So my question is perhaps difficult. Based on your work, what do you think about El Salvador?
Actually, so I came with my homework prepared. Thank you so much for that question. Just because of the time, I thought El Salvador has to go, right? But remember that we have this system of equations where we say we have 4 parameters, that is recruitment, incapacitation, conflict, and maturity. And today, for those who are unaware, El Salvador has imprisoned around 120,000 people, making it the country with the highest prison rate in the world, more than twice the number of the second country, that is United States. I think mathematically, well, first, this is going to be looking at pictures from El Salvador today with 0 human rights and total disregard of how the people is. If you are male with any tattoo, most likely now in El Salvador you were arrested, unless you are extremely blonde and white as a tourist, then you are safe, but otherwise you are here. Maybe mathematically what did happen in El Salvador, remember this scheme where I have cartels and what the police is doing? Perhaps El Salvador did change from this stable equilibrium and managed to push the football to the other side of the mountain. Maybe this is true. However, there are issues in terms of demography because Latin America is aging, not as fast as Europe, but we are aging as well. and they have roughly 10% of their reproductive males in prison. So they will actually age much faster than anywhere else. Second, for these people, they have mass trials now because the system was not prepared for so many prisoners. Then the inhumane conditions is terrible. And mass trials means a judge will be filing and will be processing roughly 1,000 people at the same time. When you process 1,000 people at the same time, you know the chances that you have for showing that you're innocent? Zero, right? We don't know what is the plan with Nayib Bukele. Nayib Bukele, the president of El Salvador, is. He is basically like a clown for me, and he doesn't have a plan for social reincorporation. Social reincorporation is what we in the Western world believe criminals do. We put them into prison for a bit of time, and then when they learn how to reincorporate into society, we kick them outside, right? And we try to give them some work and so on. And that's how the Western world works today, except for the highest of the crimes, right? Well, do they have a plan for social reincorporation? No. So what will happen with the criminals, 100,000 people that are today in prison? They are 25-year-olds. Most likely they actually will end up 50 years in this prison. And will the state have enough budget for paying for this? Is there a state capacity for dealing for this? Or is there even a long-term plan? Because today you arrested in El Salvador every criminal or every pretended criminal that is between 15 to 25. In 5 years, will you arrest also those that are 10 years old today? Because like the system has to grow, right, and evolve. Because we believe that that doesn't happen and that this is not the solution for Latin America. We actually pushed another article in Nexus that is relevant for Mexican elections. Should other countries follow El Salvador? And the answer in this article is no, please, let's not move in this direction because we are totally unaware of all the negative consequences that this has. So I don't believe El Salvador has the solution.
Thank you very much for the very nice talk. Okay, I had a lot of questions, but I'll just skip to this ultimate section, which I think it could have been a talk in and of itself. Actually, I'll divide it into first. Did any of the news outlets, news services that you spoke with, did they know that your estimate came from a model like this? Because I think some of them, they don't really trust, like, you know, doing mathematical modeling or, I don't know, simplification of a real case. And the second one is, I think that the curve that you showed us, which you said, here was the term of this president and here was the term of this other president, it looked very, like the incidence of crimes, it looked very policy dependent, no? And I believe that you used fixed parameters, whereas this curve looked like it was very, the policies would mean a change in parameters. So how did you use it? I mean, which part of the curve did you use to fit the data, or how did you do this?
Thank you, Jesus, for your questions. First, for the media, to be honest, well, in the police, I frequently also was exposed to media because you need to talk to a journalist that know about cameras or something like that in Mexico City. But I've never in my life before was something like this. And the article got published on a Friday. The Monday after the article got published, I was interviewed 17 times on a day. And doing 17 interviews, the last one was at 3:30 a.m. because it's Mexico, so 3:30 in Austria. Was for me crazy. But that question was super interesting. Here is Adela Micha. She's extremely famous in La Saga. She wanted to know about the result, right? How did you get the result and so on. The plan was for me to be with her, I think 7 minutes. She gave me a full hour to discuss models, data, how confident do you feel? Would it be possible that it's 300,000 or that it's only 20,000? How do you feel about your family, about being in Mexico? what's your experience in the police? Then Karen Aristegui, that she had me in her program and in MDC. She had me try exactly for the same reason. No, come, it's mathematics. We need to understand it better. Explain what's the model, explain what's the origin of this data, explain and explain more. And I felt responsible. I know that being in the spotlight of the media sometimes sounds exciting, but at the same time I felt responsible for, if I threw a number to my country like 175,000 carton numbers, now you go and explain it. And now you go and every single newspaper that asks, every reporter that wants to talk to me, I will say yes, even if it's 4 a.m., because I have now a responsibility to explain as good as I can where this result came from. So that's what I did. And honestly, most of this media, Gaby Frias, also fantastic, CNN, she had me twice, once talking about the model and once for answering to the president of Mexico when he called me a traitor. Like most of the media was super interesting and engaging. So the experience for me was the opposite to what you perceived it was, except maybe for one of these in the US, where I had maybe 1 minute. Also, in Mexico, there are how many cartel members? Thank you very much. And that they hung up. So I was live, I think, in Fox. I mean, that was like just to show the gimmick of the number, right? And now in terms of the policies, yes, there are many things to look at. And it's true that it's policy dependent. And it's also policy dependent at the city level. Cities like Ciudad Juárez were extremely insecure and then secure. Cities like Acapulco, secure and then insecure. In 10 years or maybe more, crime fluctuates, right? So it's true that at the local level, we need to do more. And that was for me part of what I try to do now. First, I'm trying to apply for more grants for using this model for now disintegrate this at the geographical level, at the policy level, at the interaction level. Can we do something in El Salvador or Guatemala or Nicaragua or Ecuador? So I'm in contact with the UN in Vienna to try to get more money into doing more of this research. For me, the idea is at least once in Mexico, we have some idea of a result or something that we can do. Okay, now let's follow this path, right? So that's hopefully what will happen in the next few years. Policy dependency, here there is nothing. That means I only have as input, casualties, and homicides. At the national level, nothing more. But hopefully, if you see me in 2 years, you will see, now he has results for Acapulco and Ciudad Juárez.
Okay, so let's thank the speaker again. Yeah, someone think I see yes, okay.
Muchas gracias.
Supongo que estabas en Valladolid estos días.
Sí.